All right, so here's a question that was asked over email, and it's question 3.4.39, and they ask you to use the given zero to find the remaining zeros of the function. They give you this function right here, and they tell you that one of the zeros is 4 minus 5i, and then they want you to enter the remaining zeros. Okay, so the first thing is, when they give you a zero like this that is a complex number, the conjugate of a complex number will also always be a zero. So the conjugate of this number right here, this complex number, is going to be 4 plus 5i. So right away we know that both of these are going to be zeros. And the thing that we have to do is we have to use these zeros in order to find the quadratic that they came from. So, you know, at some point this would have come from a situation where you had x equaling 4 minus 5i and x equaling the 4 plus 5i. So if you'd gone through and you'd done all your solving, whatever quadratic you were working with, to get these as a result, you would have ended up here. So we're kind of working backwards right now, okay, to see where this came from. So if I were to take each of these pieces and set them to 0, then I would see that this is, you know, if I subtract 4 and add 5i to both sides, then I would see that this is x minus 4 plus 5i equal to 0 is where that would have come from. And then this one, x minus 4 minus 5i, is where that one would have come from. Okay, so if I actually take both of these and multiply them, I'll see the quadratic that it came from. So I'm going to take x minus 4 plus 5i, that's this one right here, and multiply it by this one right here. And I'm dropping the equal to 0. I mean, that's how we solved it, but I'm really just concerned about finding the quadratic at this point. Okay, so if I multiply that out, I'm just going to take the x, distribute through, negative 4, distribute through, and then 5i, and distribute through. So this is going to be x squared for the first, and then minus 4x, and then x times negative 5i, so negative 5xi. And now I take the negative 4 through, so it's negative 4x, and then it's going to be a positive 16, and then a positive 20i. And then I'll take the 5i through, so this is a positive 5xi, and a negative 20i, and then the last one there, negative 25i squared. Okay, so if we collect some like terms here, you're going to see that there are no like terms for the x squared, so that one just comes down. This negative 4x and this negative 4x, that's going to give us a negative 8x. Okay, and negative 5xi and positive 5xi, those will add to be 0 because they're opposite in sign. We also have this adding to be 0, positive 20i and negative 20i. Okay, so, and then we're left with right here, we have a positive 16, and notice right here, negative 25i squared. Remember that I squared is a negative 1, so this is actually a negative 25 times negative 1, which ends up becoming a positive 25. So I have this positive 25 and this positive 16, and that's going to give me a positive 41. Okay, so now this is one of the factors of our original quadratic here. Looks like this thing is misbehaving. Okay, there we go. So this one is one of the factors of this original function that we're working with. Okay. Okay, so in order to find the other factor, the other quadratic factor, what we're going to have to do is take this quadratic right here and long divide it into our original function. Okay, so it's gonna look like this. So we're taking the x squared minus 8x plus 41, and we're going to long divide that into this big, long quadratic. So x to the fourth minus 12x cubed plus 28x squared plus the 196x and then minus the 1845. Okay, so with long division, what we're doing is we're taking a look at taking first term and dividing it into first term. So first term divided into first term, that's going to tell us what I'm going to put up here, and then I'm going to take whatever I put up here and multiply it through this whole thing in order to get this line. Oh no, looks like the picture is malfunctioning. I don't know what that's doing. Okay, well, I guess we'll just go with it. All right, so if I take x to the fourth and divide it by x squared, then I get x squared. So I'm going to put x squared up here. And excuse me, I'm not paying attention here. X squared times x squared is going to give me x to the fourth. And then if I take x squared, multiply by the negative 8x, that's going to give me a negative 8x cubed. And x squared times the 41 is positive 41x squared. Okay, now what we're going to do now is change signs. All right, so this is going to go negative. This is negative, so it goes positive. And this is positive, so it goes negative. And you have to keep track of that because you're actually subtracting the whole thing here. Okay, so we can see x to the fourth cancel. We have negative 12 and a positive 8, so that's going to be a negative 4x cubed. Positive 28, negative 41, so we're going to get a negative 13 there. And then I'm just going to bring down the rest of my problem. Okay. All right, now we just do it all over again. I'm going to take this negative 4x cubed and divide it by x squared. So, you know, I mean, if I was to do this off to the side here, really what I'm doing is I'm taking negative 4x cubed, the first term, and dividing it by the first term and just simplifying that. And I see that I get a negative 4x. That negative 4x is going to be what goes up top here. And then I'm taking the negative 4x and distributing it all the way through. Same thing that we did in the first line. So negative 4x times x squared gives me negative 4x cubed. And then I have a positive 32x squared. And then 41 times the 4 looks like 164. So negative 164x. Okay, and we do the same thing again now. We're gonna change all the signs because we're subtracting the entire line, which means we'd have to change this to a positive, change this to a negative, and change this to a positive. Okay. All right, so these cancel, had to be 0. We have negative 13 and negative 32, so that's negative 45x squared. And then we have a 196 and a 164, and that's going to give us a positive 360x, and then bring down this 1845. And we do it all over again. So we take first term into first term, this negative 45x squared, divide it by the x squared, and you know, you can do it off to the side if you need to. You see the x squareds are going to cancel, and you have a negative 45, and that's what you're going to place up top. Okay. So negative 45 up top, and I'm going to take this through and multiply it through all of that. So it's going to look like negative 45x squared. The negative 45 times the negative 8 is going to give me a positive 360, and then I just have x. And negative 45 times positive 41, that's a negative 1845. Now what you see here when you change signs is that, you know, all of these are going to cancel and you're going to have a remainder of 0. And you should expect that, because if this is one of your factors of your original function, then it has to divide evenly into this. So you should be able to get another quadratic out of this that has a remainder of 0. Otherwise, you've made a mistake somewhere along the way. So now what we're trying to do, we know that this quadratic right here, well, actually, let me just write this out. What we actually have now is we have our original function, h of x, and we have it factored into these two different factors right here. So it actually factors into x squared minus 8x plus 41 and x squared minus 4x minus 45. Okay. Now, this we've already, that was already solved. This gave us the 4 plus or minus 5i zeros, this one right here. Okay, this one we have yet to solve. That was the whole goal here, was to get the other quadratic that made this thing up so that we could find the zeros that come from this part of the factorization. Okay, so what we want to do at this point then is take our x squared minus 4x minus 45 and set it equal to 0. And that's going to give us the zeros that are coming from this quadratic. Okay, and this one actually factors. If it doesn't factor, then you need to stick it into the quadratic formula. But it does. It's going to factor with a 9 and a 5 and a minus sign and a plus sign. Okay, and then set both of these to 0 and solve. So you get x equals 9 and x equals negative 5. These are two of your zeros. The other two zeros are 4 minus 5i and 4 plus 5i. And remember that you can look at the power on your function to determine how many zeros total there are, both complex and non-complex, complex and real. So there's 4 of them. Here's 1, 2, and 3, and 4. Okay.